today's video, we're going to look at function composition. Function composition is where we put two functions at least together and we compose them. So we put them into one new function, two parts into one. This first example, we're just going to look at how we plug a number into a function composition. So for example, if he has to evaluate f of g of 48. So we say this as f of g of 48, question mark. So we're looking for a number at the end of this problem. And we're going to start with the inside first. So notice we're going to start with the function g. We're going to put 48 into g, and where x is. So we're going to do the square root of 48 plus 1, and then we're going to subtract 3 at the end. Notice we get square root of 49, and then we'll take 3 away at the end. So 7 minus 3 is, of course, 4. And the way we say this is g of 48 equals 4. That's the first part. Once we have the inside part done, we take that output 4. So notice we started with an input of 48, ended up with an output of 4, and this becomes g of 48 equals 4. And one important point to make here is this is an ordered pair. So as we go forward, I want you to think about function notation as useful, and the fact that we're given an ordered pair by just looking at the expression. Okay, next up, now that we have g of 48 equals 4, we go to the second layer, which of course is the function f. And we're going to take that 4, and that output for g becomes our input for f. So f of 4 is what we're looking for. And of course, that's a nice linear function. 3 times 4 plus 1 equals 13. And finally, we say f of g of 48 equals 13. You say, why in the world would I want to work with function composition? It's a good question. And I'm not sure there's a really good answer, except that math is fun and math is good for the brain. Okay, the next example, I'm going to look at a Khan Academy problem here. So in this Khan Academy example, we have g of x and h of x. And notice it says g open dot h of x. So one thing to point out there is that once we can write it a couple different ways, that is the same as what we were just doing on the last slide, which is g of h of x. And so if we were to look at that, just to rewrite it, and when you see open dot, it's the same as function composition. That would be opposed to closed dot, which is multiplication. Okay, so for this example, we have g of h of x. And notice I've left an open spot here in the rule g because we're starting with h. So we start with h because that's on the inside. Okay, and so the inside piece is the function that we used to plug in to the other one. So in this case, we're plugging h into g. Okay, so it looks like this. Basically taking the rule for h, 4 minus 3x, and we're plugging in again where we see x in the rule g. All right, now in this case, we have a squared rule, x squared. So just to remind you guys, we're going to take a square to calculate that. So we're going to actually use our 4 minus 3x on the sides of our rectangle. And we'll multiply to get the boxes like we did before. So we have multiplication all the way here. And we have our final piece there. So we're multiplying to get the pieces. And once we get those, we can see we have 9x squared minus 24x plus 16. And you may be asking, where's the minus 24x coming from? Well, that's our 2 minus 12x's here. We're going to combine those together at the very end. Okay, so we have plugged 4 minus 3x into our rule. We've taken care of the squared part, and we've rewritten it. And we have to be real careful at this stage because it says 3 minus this rule. So we're doing 3 minus whatever we got for the x squared part, which is here. Okay, so our last stage is just to combine any like terms. The only like terms we have is 3 and minus 16. Now we do have to apply this negative to everything in the rule there. So we have g of h of x equals negative 9x squared plus 12x minus 13. In the next video, we'll be looking at more function composition. So we'll be looking more at domain of range and context. So please stay tuned.